Okay, this is the 8.3 quotient of powers property. And this property says that to divide powers with the same base, we are going to subtract their exponents. So here we can see that if they have the same base, we are going to do the power of m minus the power of n. And with numbers, if we have 4 to the 5th over 4 squared, we will get 4 to the 5 minus 2 power, and 5 minus 2 is 3. And we know this works because if we list out what the powers mean, then we're going to have 5 4s up here and 2 4s down here. And then since they're all multiplying, we are going to cancel out 2 on the top with the 2 on the bottom, leaving just 3 of them. So we know that this property works. So here's an example. If I have 3 to the 9th power over 3 to the 3rd power, I would have 9 minus 3, which is 6. So here's another example where we have negative 4 to the 10th power over negative 4 to the 7th power, and we're going to subtract 10 minus 7, which again is 3. And this negative stays inside because it is part of what is being repeated. It's the entire base is the same between the two. On this one, we have x to the 7th minus x to the 6th. And 7 minus 6 is 1, so that's leaving just x to the 1st power, or you could write that as just x. Here's one a little bit more complicated. 2 to the 2nd power over x to the 5th. Times x to the 5th over 2x. So the 2's are going to reduce each other and the x's are going to reduce. So we'll have 2 to the 2 minus 1, which is 2, and x to the 5 minus 1, which is 4. And then these were multiplied on the same level, so they're multiplied here in our answer. Here we have one that is all 6's. So we have 6 to the 7th power, 6 to the 3rd power over 6 to the 5th power. And we are going to use our property from before, and we are going to add the 7 and 3 to get 10, and then the 10 minus 5 is going to give 6 to the 5th for our answer. Here we have a power to a power, and that's review from the other day. So we have 3 to the 5th to the 3rd power, and when it's a power to a power, we are going to multiply them. So this is just going to be 3 to the 15th power. Here we have x to the 8th, x to the 6th squared over x times x to the 4th squared. So the first thing we're going to do is distribute this 2 on the outside, and it's going to get multiplied to each power on the inside. So we could distribute, like I said, or here I wrote that we are going to add them together and then do power to a power and multiply these to get x to the 28th over 10, and 28 minus 10 is 18. So our answer is x to the 18th power. This one, we have a couple of parts going on. So we have x to the 3rd times x to the 6th all to the 4th power over x squared, and that is being multiplied by x to the 4th over 6 over 1. So if I take this first fraction, and I'm going to simplify that here, I can do 3 plus 6, which is 9, and 9 times 4 is 36, minus the 2 to get 34. And then the second fraction, I will do x to the 4 minus 1 equals x to the 3rd. So then I would have x to the 34th times x to the 3rd, because our two fractions are being multiplied together there. And then 34 plus 3 is 37 for our answer. All right, the projected population of Tennessee in 2030 is about 5 times 5.98. And Tennessee has 5.59 to the 6th square miles. Predict the average number of people per square mile in Tennessee in 2030. So to get people per square mile, we're gonna put how many people we have in the population over the land area. So that is 5 times 5.9 to the 8th power over 5.9 to the 6th power. And the first thing I notice is that I have two 5.9s as the bases. So I can subtract 8 minus 6 to get 2, and then I can find 5.9 squared to get 5 times 34.8, which is 174.05 people per square mile. But usually we don't have decimals or parts of people. We would just say 174 people per mile.